Hello friends. In this opportunity, we will learn to use a color sensor RGB module with reference TCS34725. Using a microcontroller, such as an Arduino-compatible nano board, and programming with the Arduino IDE, we can bring objects closer to the sensor at less than 1 cm to obtain the numerical composition of color. And from these data, interpret what is the color of that object. The color sensor can be applicable for detect the freshness of perishable items, detect and correct the color of lighting, drive ambient light based on the content of a screen, and of course, detect and sort objects by their color. Observe RGB color detection with the TCS34725 sensor. Interpretation of the RGB composition with the Arduino board. And finally, the rotation action with an SG90 servo motor. Welcome. This is the wiring diagram we will use between the TCS34725 color sensor, the Arduino compatible nano board, and the SG90 micro servo, with which we will develop the practice for detection and sorting of objects by their color. With the servo motor and the color sensor connected to the Arduino board, and the latter, connected to the computer through the USB cable. We open the Arduino IDE software and open a new file. In the description of the video, I leave you the link to download the Arduino software from the official page, in its most up-to-date version. We are going to install a library that allows us to use the color sensor, in a very simple way. To do this, we go to Tools, and click on Manage Libraries. In the Library Manager we make sure that, under Type, all is selected, and, under Topic, all is selected. In the search bar we type TCS34725, which is the color sensor reference. And some available libraries are displayed. For sure, with any of these libraries you can operate the color sensor very easily. For my preference, I will select the library of the Adafruit company. We select the latest available version of the library and click on Install. The Library Manager tells us that other dependencies need to be installed for the library to work better. We click on Install Everything. Once the library is installed, we can close the Library Manager. We can click on this icon to close the window. Then, we place the cursor in the scope. The scope is the empty space at the beginning of the Arduino IDE editor, outside of all the methods, in which we can create objects and declare variables globally, to use them later in the code. And we go to Sketch, or Program, we go to Include Library, we search and click on the Adafruit TCS34725 library, to include it in our current program. We then create the object that will allow us to operate the sensor in our program. We type the name of our preference, I will name it TCS. And in the creation of the object, we place two arguments separated by commas inside the parentheses. The first argument is the integration time of the sensor, which I will set in 50 milliseconds. And the second argument is the gain of the sensor reading, which I'll set at a value of 4. While we develop the program, the RGB color composition readings obtained by the sensor will be displayed in the serial monitor tool of the Arduino IDE software. For this we will use the physical serial interface of the Arduino board to send this information to the computer by a USB cable. Then we go inside the void setup method. To do this, we initialize the serial interface of the Arduino board with the begin method, and we set the transfer speed of our preference, in this case, with 115,200 bauds, or bits per second. We then initialize the color sensor with the begin method. Then we go inside the void loop method and create 3 variables for the color composition RGB, red, green, and blue. Afterwards, we obtain the reading of the RGB parameters with the sensor, and we store them in the 3 variables that we created previously. With the print method, we transmit to the computer the plaintext R, a colon, and a space. Then we transmit the integer number of the parameter red. This will be a number between 0 and 255, representing the red component of the color that we have in front of the sensor. We transmit to the computer the plaintext G, a colon, and a space. We put some blank spaces before writing the letter G, just to format it and not be so attached to the previous text. Then we transmit the integer number of the parameter green. This will be a number between 0 and 255, representing the green component of the color that we have in front of the sensor. We transmit to the computer the explicit text B, a colon, and a space. Then we transmit the integer number of the parameter blue. This will be a number between 0 and 255, representing the blue component of the color that we have in front of the sensor. Finally, we write the println method, to finish writing the current line of text, and move on to the next line. Then, we select the hardware. For this we go to Tools, and we select the board that we are using, in my case, the Arduino compatible Nano board. And we select the port in which our Arduino board is connected, in my case, COM5. Then, we click on the Verify icon to review the code and rule out any syntax errors. And we click on the Upload icon, to upload this program to the Arduino board. Then, in the upper right part of the software, we click on the serial monitor icon. In the serial monitor, we make sure that a baud rate of 115,200 is selected in this case, that is, the same one that we programmed to the Arduino in its serial interface. And we can already see on the serial monitor, the 3 RGB color components as a number. We are going to scale the serial monitor data momentarily to get a better view of it on the screen. So, we are going to bring 4 colored elements closer to the sensor: blue, green, yellow, and red. This, to know the RGB values or components that the sensor recognizes for each of these elements, and thus being able to classify each element in the Arduino within its respective color. Let's start with the blue. Let's continue with the green. Then the yellow. And finally, the red. In this way, we already know the numerical representation of color RGB for each of the different colored balls. Now, let's write in our program conditional control structures, of the if type, that allow the Arduino to recognize which ball is in front of the sensor according to its color. To do this, let's place the cursor one line after getting the sensor data reading, and store the sensor readings in 3 variables, which I'll name according to my preference, R, G, and B. These variables will contain the 3 numeric values that we can see on our serial monitor on each line. We are going to create a string type variable, where the descriptive text will be stored in the color of each ball, that is, for possible texts, red, green, blue, and yellow. Then we create the first if structure, to detect the red color. As we can see in the RGB readings of the red ball, we can see that the R component is considerably higher than the G and B components. It exceeds them by at least 50 units, for which we go to place in the conditions of the if, a conjunction that relates the 3 components. R minus G is greater than 50, and R minus B is greater than 50. If this condition is met, we will be able to know that we are in the presence of the red ball, and we will assign the explicit text, red, to the color variable. And in the data transfer towards the computer, we are going to add the transmission of the explicit text, color, and of the variable or string of text, color. When uploading the code to the Arduino board, on the serial monitor we can already see the color text, next to the 3 RGB components. Here we will show the color that we recognize from the ball that is in front of the sensor. Then let's write the second if structure, to detect the color, green. As we can see in the RGB readings of the green ball, we can see that the G component is higher than the R and B components. At least 10 units higher than the B component, and by at least 30 units higher than the component R. For which we are going to write in the if condition, a conjunction that relates the 3 components. G minus B greater than 10, and G minus R greater than 30. If this condition is met, we will be able to know that we are in the presence of the green ball, and we will assign the explicit text, green, to the color variable. Then let's write the third if structure, to detect blue. As we can see in the RGB readings of the blue ball, we can see that the B component is considerably higher than the R and G components. At least 20 units higher than the G component, and at least 40 units higher than the R component. For which we are going to write in the if condition, a conjunction that relates the three components. B minus G greater than 20, and B minus R greater than 40. If this condition is met, we will be able to know that we are in the presence of the blue ball, and we will assign the explicit text, blue, to the color variable. Then let's write the fourth if structure, to detect the yellow color. As we can see in the RGB readings of the yellow ball, we can see both the R component and the G component are considerably higher than the B component, in the same proportion. Both components, R and G, at least 40 units higher than component B. For which we are going to write in the if condition, a conjunction that relates the three components. R minus B greater than 40, and G minus B greater than 40. If this condition is met, we will be able to know that we are in the presence of the yellow ball, and we will assign the explicit text, yellow, to the color variable. So, let's upload the program to the Arduino board, and try bringing the colored balls closer to the sensor, and see the result of the data on the serial monitor. The blue ball. The green. The yellow. And the red. As we can see, the Arduino recognizes the colors of the four balls. Then we will place 3 angles of rotation to the servo motor with reference SG90, which allows the color palette to be rotated to organize the balls in 3 different colors, red, green, and blue. The SG90 micro servo has a total turning angle of 180 degrees, so we will divide this figure into 3 small balls. So, the angles we assign to each color should be 60 degrees apart. To do this, we go to the scope of the editor, and we include the Arduino servo library that will allow us to assign direct angles to the servo. Then we declare the object that will allow us to operate the servo motor, with the name of our preference, I will call it Servo. Inside the void setup method, and using the attach method, we assign the Arduino pin where it is connected, or where the servo will be connected, in this case pin 9. We go inside the if, which detects red, and we write to the servo an angle of 30 degrees. We go inside the if, which detects the green color, and we write to the servo an angle of 90 degrees. We go inside the if, which detects blue, and we write an angle of 150 degrees to the servo. And voila, we have completed the program. We upload the program to the Arduino board. To make the model, use a sheet of balsa wood 25 mm wide by 5 mm thick, and cut 3 sections of 20 cm using a scalpel or the cutting tool of your choice. Draw the markings and cut a 20 mm wide section for the subsequent insertion of the TCS color sensor. Using glue, such as liquid silicone or the glue of your choice, glue the 3 sections together to create the channel that the little ball will slide through. On a sheet of balsa wood, 15 cm wide by 3 mm thick, draw a circular section 14 cm in diameter using a compass, and cut a circular section using scissors. Using a drill or rotary tool, and a 5/16" drill bit, drill a hole in the center of the circular section. Build a stable base for the servo, for example, using 4 sections of 10 by 10 mm balsa wood, and screw the servo to the wood using the 2 accompanying screws. The servo comes with a plastic arm, which is inserted into the motor shaft to transmit rotational mobility. We'll glue the ends of this arm and glue it to the center of the circular section of wood, with the hole for the servo pointing into the wood. Then we create the circular color palette, in the PowerPoint program for example, with at least 3 sections with 3 different colors, and we print it on self-adhesive paper. We cut the self-adhesive paper circularly to obtain the circular palette of colors. Then we expose the adhesive and stick the color palette on the circular section of wood. From a piece of flexible cardboard, cut a rectangular section with a length determined by the perimeter of the circular section of wood. Put glue on the edge of the circular section and glue the flexible cardboard section on it. Cut square sections or circular bars of balsa wood to the dimensions shown on the screen. And glue them together to build vertical structures that will support the ramp for the little ball. To know in which position to fix the servo structure, we can electrically connect the servo to the Arduino board, and momentarily load the code shown on the screen to the board, with which we will place the axis of the servo at an angle of 30 degrees. With the servo positioned at 30 degrees, let's insert the servo in the color palette, and manually rotate the entire structure, to where it should be positioned when it receives the command from the Arduino to be placed at 30 degrees, that is, with the red compartment in front from the end of the ramp. Then, using appropriate length sections of wood, lay out the spacers for each color. Finally, locate the TCS sensor in the opening we made for it, and according to the wiring diagram, connect it to the Arduino board using male-female DuPont cables. Connect the servo motor to the Arduino board using male-to-male DuPont cables. Friends, I hope this tutorial has been very useful for you. Subscribe to the channel and click on the bell to be aware of new content published.